Hello, everyone. Sorry, I got disconnected, but now I'm back online. I'm just starting the YouTube recording or live streaming. How are you, Andrew? Bilal Hussein, where were you last week?
I had some other engagements. We had some installations going on in the department. Sorry, I could not join last week.
Okay.
Hi, Wamid and everyone.
Okay, so welcome all. How are you, How are you, Andrew?
I'm good, thanks.
Okay, so probably we're going to just continue, although I would like to address, well, there were, Andrew, we have a classroom where people actually, sometimes they post some of the problems and others volunteer to show them the solutions. So there were a few actually on MMCTP. Okay, let me try to go to the classroom. Yeah, let's share everything. Okay. And, so these are a few questions related to, some of them are related to MMCTP. So Saren has posted something about MMCTP error. And let's look at the error message. And it was pointed out to him that the queuing system used in the shell was NQS. So probably AT is probably what he has there. But if he has Slurm configured, then he should set that from the shell. And I think he replied back that everything works fine. So I'm just showing like this sort of errors so that people, or when they watch the video, they might get across this error. Okay, let's look at another one. Okay. So this is one. Is there an option to restart the simulations under advanced beam NRC options? Make sure that the configuration beam settings the option. Oh, that's what was my comment. So basically, although Andrew, I would like you to actually talk more about this. So basically the question, how to restart an MMCTP simulation after completion.
There is an option to restart the simulation if you go into the advanced settings. And this would be a dose XYZ simulation, I'm assuming, or is it a beam? Yeah, and see the run options pull down?
Yes.
You
and
can
then you have to restart, analyze, yes. Okay. By the way, my internet connection is a bit horrible today. Actually, it's horrible. So if I got disconnected, please, Andrew and Bilal, continue this. YouTube, I think we'll still do live streaming, but then I will try to reconnect back. So, but I think there is one thing that one has to be careful with, and you can correct me if I'm wrong, Andrew. So in the Beam NRC settings, so now, for example, I have this option to remove the W files or remote shell, and this will not allow me to actually restart the simulation.
Well,
right?
No, that's so.
So you probably
I see what you're saying. Yeah, you would probably want to turn that off. Yeah. That's
Yes.
a good point, Wamid.
Okay. Because when you're doing parallel processing, you're actually accumulating on the W files, so W1, W2, 3, and so on. After the simulation runs, I think the MMCTP is going to automatically start add phase space, and it will combine these phase space files into one phase space file. But if you want to restart, then if the W file, so if I have this option turned on, after MMCTP adds the phase space files, combines them, it will delete these W files. Just some people would like that option to save space. So if you have that option turned on, probably you cannot restart your simulation. So make sure you have it turned on or not checked. Right? That's correct, Andrew?
Yeah, that's the safest way to go about it.
Okay.
Now, if you look at some
Yeah.
of the scripts that run every time a job is launched, you can put an if condition.
Okay.
So that if it's a restart, it's not going to automatically remove those W files. But there's also the possibility that it'll remove the W files after it launches add phase space. So the safest bet is to just leave that off.
Yeah. For me personally, because I use Beam libraries, I don't generate phase space files. But it's, I mean, it's up to the user to, if you want the phase space files, that's possible. Okay, so let's look at another question. Okay. So Sarin is very excited about MMCTP. And that's nice, actually. So let's look at this error run. I looked at it and I did not have a solution. Okay. So I think what he has done, I don't know what was he doing here, but he got this message that an out of bounds exception has occurred.
It's not clear what the out of bounds exception is referring to.
Yeah.
It looks like the screen in the background, the remote shell connection, executed properly.
So it cannot open this log file for reading no such file or directory. And then, okay, I really don't know what happened there. It's not obvious. Okay. And the claim is that I'm getting this error frequently. Sarin is Sarin here? Yeah, he's there. So Sarin, explain this. What were you doing and why you got this error?
Hello. Hello, could you hear me?
Yes, go ahead.
Yeah, yes, I was trying to simulate one on field, but I could run this test run successfully. But after completing the test run, it shows, you can see the I given that screenshot also. It shows it is completed, but I was not aware of that restart option. I didn't tried it, but when I try to simulate it again after giving that checkbox, it shows this error. It's not proceeding further, and it gives this error frequently. And I have given more screenshots on that. And my last question. Yeah, it shows, and it shows it is completed because the test run was completed, but I couldn't proceed further because of this error. It shows something dot log or something, could not read that file or something like that.
I'm wondering if the error has to do with the system not finding the phase space file.
Do we know to do anything like linking this face file, or there's one window to link the face file? This one.
It should find the face file if add face space completes
Uh,
successfully.
and
Now,
I have
did
given
you,
that screenshot also. I have posted that screenshot also. That's one window, and we can open and link that face file.
right?
Yeah.
Linking, you wouldn't need to link it unless it was you were manually linking it to another face space file. But after each run, MMCTP will read the face space
Yeah,
file.
this one.
Yeah.
But it was successfully linked.
By
But
the way, Andrew, I'm getting the same thing. I'm getting the same, like here, this, I remember in the past, we should see a list of the face-based files available and to link and so on. I'm not getting that on the Mac now. So I'm getting like something like this.
I'm trying it in Windows. And this EGS is installed in a Linux system, Linux server.
Yeah.
Right.
But I'm talking to Andrew because I remember the previous versions. There should be a list of face-based files available if, for example, you want to use it to link it to the beam. So for example, you did a 10 by 10 simulation, and that 10 by 10, you can link a face-based file to it, and then
but in this window it shows
well, if you have a larger face-based from somewhere.
Right. So it appears like it's not reading the file directory properly to display the information.
But I can see in EGS system, it is getting accumulated, like the simulation is going on, but the same thing is not shown here, because that I can see the file size is increasing, W1, W2, W3 is going, but the same thing is not shown here in MMCTP.
So if you go to the...
But I think it is linked, so
yeah,
it is
here linked, but it is not shown here. But in the EGS system, it is getting accumulated, like the file size is growing up because the simulation is running actually, but it's not showing here.
Yeah, I see that it's not showing.
Yeah. That's a problem.
Yeah, but does it...
Actually, the job was submitted and the simulation is going on, but it was not shown here.
But I think the file is linked because this happens after the simulation completes, and I think everything is fine here. But there used to be an option that to list all the face-based files in the directory.
I think it's in the next tab. I like
EGS system
database. There you can see that.
No, it's here. No, it is here.
In the next tab.
No, it is here.
It was available there. The list of face-based files.
There
and the
is
same thing is linked here.
Yeah, so there's two tabs. This will show the folder and all the face-based files in that folder.
Yeah.
And the database will show more information from other folders.
In my system, that list was available, like in that next tab, face-based database, it was available. And it is already linked here.
Okay.
I think there's some issue. There might be some issue with my queue system or something like that.
Right, but going back to your original error, which was an out of bounds error, I don't see what's causing that from this information.
Yeah, this is fine. It knows that, because it's looking for this file, the log file, and then determine that the simulation is done. I think now it progresses, does some add face-based files and so on.
Yeah.
So here we're not seeing even an error in this part. Let's look at.
Okay, let me try that, because I was not aware of that restart option. I will try it.
Yeah.
Yeah.
Okay.
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 But you did have an error in your previous window that showed an out of bounds error. So if you can find more information as to what was the system doing at the time of that error, then we could figure out what was going on.
Okay. Okay.
Okay. Okay, let's look at and see if there are other questions on MMCTP.
Yeah.
Okay, here, please can anyone assist on how to run those exercises? Show from command prompt windows. Okay, I'm getting this. Okay, that's the error that you're talking about. Okay, so we'll continue with the. So I tried to create my text for density file using density correction for a new material. No output is shown. If we can open the data file using Notepad after enabling Go, okay, it shows pegs finished successfully, but the output Notepad file seems to be vacant. True, I had this several times, and I forgot what was the reason. It was something about the formatting in the name, or I forgot. Uh, I will try to get that error again, and then try to resolve it and let you know. But it's something very trivial, probably. I remember I was generating PEGs, doing this PEGs files, and when I look at the PEGs data, and when I look at the PEGs file, it was zero, blank. So I was getting this. Okay. Okay, so I will continue on doing the MMCTP. Okay, save changes. Okay, let's save it. So there were debates about, well, an issue last time about can MMCTP distinguish between a 6 X and a 6 triple F because it's identifying the beams using an integer. And Andrew went and changed that into a string. I had these two, and I think I'm still getting the problem of it still cannot distinguish between the two, and I'm not sure the entry in the DICOM file, is it actually 6x or 6? And I lost where Andrew was doing this editing in order to figure out what's the entry, the data entry in the DICOM file. Because it might be, Andrew, that actually what's written on the DICOM file is just the energy without distinction of X or triple F. But you probably know better than this, than me. So the bottom line is I was not getting a 6 triple F when I imported, the files. I was still getting 6 as a beam identifier.
Well, do you want to import a DICOM plan into a patient and just go to that line and see how that information is read in? Because we can do that for relatively quickly.
Yes, but I forgot where was it actually. Where is the line? So because I can make a break. Okay, I'm going to open now the MMCTP.
So I have the line.
Okay.
It's 505, and you'll want to go into the thread that says DICOM object under read plan. I can say that again once you have it open.
Yeah, it's opening. I tried to create a branch, by the way, so I don't know if you got notification or not. on MMCTP.
So
on
that's
GitHub.
Yeah, generally that's usually how GitHub works. Is individual users will create their own branch. I'll only get notified if you try and push that branch back into the main branch.
Okay.
And then there's an opportunity to resolve conflicts if there's any, or for me to just accept it as is.
Okay. Okay. Okay, so the thread RTOG, right? And we go to read RTOG. Is it here?
For Wamid? So that's not the right thread. This is the thread for MMCTP's internal format.
Okay.
So you need to go to a DICOM thread. So that's under the DICOM.
Oh yeah, DICOM.
Yeah.
Yeah, sorry. I was looking at thread and methods. So here, read file, read images.
Read plan.
So it's read plan probably.
Yes.
Okay.
Yeah, and then it's 505 is the line number.
How can I show here the line numbers? View?
It's when you scroll over them and you can see them. I actually, there might be a way of displaying them. Oh, but you can see them at the bottom.
Yeah. Line 50.
505.
505. So we are there. 503, 504, 505. It's here, right?
Right. Yeah.
So let's put a break. Okay. So let's run it.
And what you can do is you can more or less open up any patient you want. And
this is what I will do now.
You can import a plan into that patient.
Yeah.
You don't need to import the whole patient. You just have to read in a new DICOM plan.
Zojo released an update, by the way, 3 days ago, 1.1, 2020, 1.1. I did not download it yet. So as it's shown now, actually, I should put it somewhere. Well, that's fine. I will get the temp. Because as it's shown here, this is going to be the nominal beam energy. It is still going to be an integer. This is not what the modification that Andrew has.
No, it looks like you have an old copy of the source code.
Yes, which is fine. But at least we want to know what is the temp that is.
We want to see exactly what temp reads. Exactly. Yeah,
yes.
You're right.
Yeah.
Yeah, that's the line that I updated to be a string.
Okay. I don't know why compiling is slow today. Maybe I'm running other stuff on the computer. Or probably just by sharing the screen, that's taking some resources. Okay, so you said I can just go to import from here.
No, you still, sorry, Wamid, you still need to have a patient opened, and then you can import a plan into that patient. So normally
that's fine.
Something like this, I pick the smallest patient I have.
Yeah.
just to have a quick load.
This is it's a patient that I have created on Eclipse, and within Eclipse, just made a structure body, and I made an inner structure for heterogeneity lung. And of course, on Eclipse, you can always override, assign a CT Hansford unit for a structure. The debate or the question was, when I import this to MMCTP, would I get these heterogeneities in the plan that I import? And it turns out no, because MMCTP still reconstructs everything from the image itself, not from the, so Eclipse distinguishes the pixel values or the Hansford unit on the image, and then from the overridden Hansford unit for the structures. So when you import the images will have a pixel value of -1000, a Hansford unit of -1000, which is air. So to overcome that problem, of course, this is the patient, because that was also one of the points we had here. So this in Eclipse, when you create the patient, it still will be air. And of course, over there, you will go and assign to the body structure a Hansford unit of 0. Here, if you want this to be lung, then you will go and assign a Hansford unit of, let's say, -700 or whatever you want. But you're assigning the Hansford units on Eclipse to these structures. This does not change the pixel values or the Hansford unit for the image itself. So what you import, as here shown, this will always have a pixel value of -1000. Okay, so let's do that, Andrew. We'll go and import, and so I can do an RT plan. And go to the DICOM folder. MMCTP. And so what's usually the extension for
It's the same extension. It's the first letter will be
okay.
RP.
Okay.
So if you sort by name, you'll get all of them sorted by the type.
Okay. Okay. Okay, RP. So I'm going to take this one. It doesn't matter.
So now there's no progress bar as to what's happening, but it's reading the file, and eventually it's going to try and import that.
Okay,
and we
now, yes, so now we got there to the breakpoint, and let's look at the temp variable. So here it is. So there it is. The label is not in that. So the X and triple F are not there, Andrew.
So what I would do next is you can hit resume. You'll have to keep doing this iteratively until you've read all of the beams. But then we could look at the DICOM header for that file and see if there's something else that we can look at.
Because probably there should be somewhere where at least, okay. Yeah. So there it is, one beam. Okay, so it's not stored there. That information of triple F, it's not stored there.
If you want to look at that file again, Wimid, go File,
Okay.
and then actually maybe it's Task.
Plan. Okay. Tasks.
You want the
DICOM header.
DICOM header. And
So
if
we
you
can
pick
open
the file again, we could look at what the information is in the file so that we can maybe pull a different variable.
So just I'm going to repeat this for everyone to know what's the issue. The issue is MMCTP cannot distinguish between a 6X and a 6FFF beam. And we're trying to fix that. So we're trying to see where is that information is written in the DICOM file, and then probably we can modify or get it and fix that issue. This was written when FFF was a dream, I think. When did you start writing this, Andrew?
About 2006.
Okay.
So
okay.
What we'll have to see is if where this information is embedded into DICOM. So if you can find the beam energy section, we can see if 6 is written as just 6, or if there's a 6FFF somewhere, or how the DICOM standard has evolved.
And where is that, the beam energy?
Well, I don't know off the top of my head. You're looking through control points right now. So
can I export it to a file and then open it with the...
Yes, you should be able to. Let's see if that works. Did it dump something onto your desktop?
Okay, I'm going to check. Okay, desktop. That's a DICOM, and okay, so
yeah.
Let's open it. Okay.
So ideally, it's easier to do that if you had just a static beam, but you have all the control points in there, so it's a little more challenging to find.
Okay, so next. Okay, that's okay. We don't want that. Of course, it's getting the FFF from the the binary.
It is, yes.
Okay. Actually, this might be a 6X, so might be it might be different. It's not the FFF actually. The beam itself might not be triple. I'm not sure. The planet or should I search for beam?
Search for energy. Okay. Energy should be
energy.
Yeah.
Okay. Nominal energy 6. And anything else? Okay, I'm not sure. I'm gonna postpone this, Andrew, and I'm gonna try to get a FFF beam, and
right.
see, because I have actually 2 beams, 6 FFF and 6, and then we can probably deal with this probably the next time, because it's just going to take us some time to find which would be the appropriate beam header to look for.
It sounds like a plan. Yeah, that sounds good.
And then yeah, and also because then probably we'll also have to do it for the 10 MV and 10 FFF and see if it's consistent. For example, things are very consistent with that. Okay. Okay, then. So I'll close that. So this is something for next time we can look into. But this is a nice feature where you can have this DICOM headers. And reading a DICOM file, I was trying to make a code to read a DICOM file, and I just gave up.
It's more complicated than you think it's going to be.
Okay. Yeah, it is. It is because you have to read binaries and see. It's not easy. Okay. So let's. Okay, I'm gonna close this here. Let's see. And I'm going to open the regular app that I have installed. And we'll go to File, Open Patient. So the patient, this is the patient. So as I mentioned, this MMCTP will by default convert or assign Hansford unit from the pixels of the image. In this, whenever I'm not sure about Monaco, but with Eclipse, the image, all the pixel values had a value of -1000. So MMCTP, if I just use that image to assign the material, I'm going to get error everywhere. So you have to then use the structures in MMCTP to assign materials or media that you have. And I will show you what I've done. Okay. I'm just waiting for it to finish reading the values. So in the Eclipse, the phantom is, we have a body structure, and then I have a long slab. And the phantom is, I think, 40 by 40 by 40 centimeters. And I've imported the dose distribution for two beams. One is the 6X and one is the 6FFF beams. I'm just waiting for this to finish. Okay. So if you have turned the default, I think in the those, because I turned it off, but if you have this turned on, let me show you exactly what I'm talking about, those XYZ settings. So if you have here the automake turned on, this will automatically generate those matrix with, or sorry, material matrix, let's call it that thing. or X phantom file directly from the pixel values in the image and using the CT calibration curve you have. So if I'm going to generate new, and I'm just going to generate, this is the default value, and you will see that everything is going to be assigned as air into the phantom file. Here I have, what I've done is I went to the body structure. So when I was generating the phantom, I selected the body structure and assigned it water, H2O 521, that material file, and gave it a density of 1. So as shown here, the density, because this is now, I'm showing just the density information, it is 1. And if I click on material, then everything is going to be water. Okay. Now, on this one, so when I generated the phantom, I've assigned first to the body water, and then to the structure, this structure, which is lung, I assigned lung material. So if we go and edit look at the file, then material, so if I do this, so now I have water and lung. So let's do that. And if I go, I think somewhere here, yes. So you can see the slab of lung. So this is one cut, one cut. This is lung, the material is lung, and then outside is water. If I put the density, you'll see also the densities are different. I think this is, I assigned it 0.26, and for water is 1. Unfortunately, I cannot, well, I have to, because I'm assigning it actually in the treatment planning system. So probably it's not, if you want, for example, to generate or you do a calculation with Monte Carlo using the same parameters that you used in generating the phantom or heterogeneities or materials in the Eclipse, then you have to look at the properties of the material. And obviously, you're going to use water for both, because that's how Eclipse works. So this will be water. So when you assign the material, it's going to be water for both. But the density for the lung, you will use what the density, what has been used with the Eclipse, assign it to this structure. And for the body, you're going to assign it to 1. So if you want to reproduce what a treatment planning system, those calculations has done, is, remember, there is just water. So you need to do water for both material. The advantage of Monte Carlo is then you can actually assign a different material and look at what differences that makes. And as Andrew mentioned, that usually the difference is negligible, or clinically it's really irrelevant. This is now, this is actually the dose distribution that I have imported from Eclipse. This is for a 10 by 10, and the other one, let's see if, okay, I know why, because this is on. I think because I'm assigned, it's still doing something. It has a task. That's why I cannot change. Okay, so this is what has been calculated with Monte Carlo for a 10 by 10 field, and this is the dose calculation from Eclipse. Obviously, there is more dose than what's this calculation, because in this calculation the phantom is fully water. I did not actually do a calculation with any heterogeneity corrections. I'm waiting for this other calculation to finish and to compare this calculation where I have lung heterogeneity with the dose distribution from that was generated from Eclipse. Okay, so this dose distribution is with heterogeneity corrections. And we can look at the dose profile. Let's look at the view. Dose profile, and let's look at the so let's look at the PDD. This is so probably this is 0, minus 19, 0, 0, 19, 0. So what I'm doing here is I'm just putting the coordinates of the points that define this line profile. So the first one, this is X, Y, and Z. X here is 0, so that's the left and right. Y is the up and down, so this is where the 0, 0 coordinate of my phantom is, minus 19, that because the phantom is 40 centimeters, so this should take the profile from the surface of the phantom, minus 20, I should put here minus 20. Okay. And 0, that's on the soup inf direction, that's the Z. And this is the other point, 0, 20, and 0, it's this red point. So I have shown, and now we hit on, I will select the dose distribution that I want to calculate profile. So after selection, we'll calculate. We'll get two profiles. One is for the Hounsfield units. And of course, if I select this one, I'll get just a straight line, minus 1,000 for all of them in this case. But we want to look at the dose actually. So when I show this, and I think it's across the Y. So let's change. Okay. So this is the dose distribution according to Eclipse, the treatment planning system, with this part having the lung heterogeneity there. Okay. So this one, as I mentioned, it's a dose distribution calculated without heterogeneity from Monte Carlo. So let's do a comparison. I still have a problem for normalizing both. So I'll just normalize to the maximum because I don't have my beam yet calibrated output-wise.
Wamid,
Yes.
one thing, normalizing to the maximum should work.
Yeah.
You can also normalize to a point, like if it was an X.
Oh, really?
Yeah, if you want to normalize to, if you look, it's a Y profile, correct? So you can say...
It's a Y profile, yes.
So if you want to normalize to Y equals minus 10, you could do that. And then both of those points would be the 100 point.
So where, so where do I put this?
So if
here,
you put,
where do I?
In the normalization value, you click on the norm value.
Okay.
And type in Y. This is going to be a little complicated,
Okay.
but just type in Y equals negative 10.
So minus, it's actually, so 18.5. Okay, that's
Sure.
Dmax.
18?
Okay.
Yeah. And then enter.
Yeah, so Y equal minus 18.5. For both, right?
Right.
Okay, you know, that's something I did not know.
No one would know that.
Yeah. You have a lot of secrets. Okay, that's really nice, a nice feature. Because we often, I had this problem, the beam is not calibrated, so usually but then with Monte Carlo, sometimes the maximum is not at the same point or reference point. I like this feature that you normalize to a reference point, and that's it. Okay, so obviously the Monte Carlo, it's this one, and there are no those heterogeneity corrections applied to the Monte Carlo calculations. So my Raspberry Pi cluster, I have reformatted it actually. I want to use Dockers and Kubernetes to have some websites running in conjunction to the cluster. So I'm using my virtual machine clips, Ubuntu virtual machine on the Mac. And probably that's why my machine is a bit slow. So this calculation is still running. It's a bit slower than having 68 cores to do the calculation. But we will see. So probably, I don't think maybe today we'll have it finished, but I'm going to try to at least maybe present some of these results next time and so on. This is just so that I come back to the original point. This is the phantom generated without just using the pixel values or the image. And sorry, we have to view it. Okay. And you can see MMCTP just assign air material to all of everything inside that body structure, because the pixel value is 1 minus 1000. Sorry, it actually used water, but with a pixel Hansford unit of minus 1000. So the material is water. So if you look down here, or if you look at the color label, it's water. It is correct, but the density is wrong, because the pixel value is minus 1000, and minus 1000 from the CT calibration curve corresponds to a very low density, like an air density. So that's the issue. So to overcome this problem is very simple. When you generate, you will just select, okay, use this material for overriding the body structure, and this is what I've done. So I can do 700. So now 700, and assign it a density of, Andrew, if the density is 0, would it actually take the density that's the default density of the material in the PEX file?
That's a good question. I'm not sure what DOS-XYZ will do when it reads in a density value of 0.
Okay, what I will do now is I'm going to leave it. Okay. So I'm going to leave it as 0 and see what's going to happen. Okay.
Yeah.
But what I've done is I put this to be 1, and for the lung I put 0.26. So for lungs, if you want to repeat the dose calculation from the treatment planning system, you still have to use water for this material. Okay, and then you give it a different density. Obviously, here I have to change the density. You cannot use the same default density, but you can assign. Well, so let's take that structure, and I'm going to actually use bone 5:1 ICRU. Okay, this is a label. Just don't worry about it, and so everything outside. Find the CT. I'm going to use. It doesn't matter here, because I'm overriding whatever the CT values. I'm going to put here, boom. And we're going to generate the phantom. I found it quicker actually than going pixel by pixel and converting the pixel value to CT numbers. So now it's just writing, and I think it should finish by now. By the way, are there any questions? Bilal, you should have questions.
I have not tried the MMCTP. I'm not able to actually see that.
Okay. How is Slurm going
That's
with you?
perfectly. That's perfectly working.
Okay. Good.
In fact, actually, I actually found out a way to change the other values also, like the preference values and other things. So nice values.
Okay. Okay.
I'll let you share with you that thing.
Yeah, probably you need to give us a presentation
Yeah.
on this too. Andrew, are you using a queuing system in your center?
Yes, we also use
And
the
what's that?
Slurm one.
Slurm, okay. Did you configure it yourself, or you have someone doing that?
Oh, I have somebody that manages the IT infrastructure for our department, and he's really good at doing stuff like that. His name is Cody Cruson. You might notice him on the EGSnrc forums. Quite active.
Okay. So if we have questions about Slurm configuration, you think he can help us?
I would say absolutely he can help you.
Okay.
Yeah.
We have it running, no problem. The issue for us is when it runs, it's running at zero nice value. I want to find a way to actually run it at the lowest priority.
Okay.
I know. So probably I will be in contact with you. Okay. So it seems it does not work, Andrew, because the density is 0. So although the materials are correct, let's look at that. So there is water, and if I go here, probably this is the bone material, but the density is 0. So it seems it does not take the default, or maybe when you do the calculation, it does take the default. I'm not sure. I probably have to submit the calculation and see if I get a distribution that makes sense or not.
You're seeing the exact behavior I would expect. It would use the override value that you entered.
Yeah. Okay. So
now,
we have to, yeah, okay, go ahead.
Was your question, what will DOS XYZ do with this information? Is that what your question was? Or
Well, if I submit this, okay, then nothing will be calculated because it's vacuum. The density is 0.
Yes. Yeah.
Right. So I'm wondering now when I submit this, because one has to be careful. Does those XYZ, is it smart to see that the density is 0? Is it going to take the default density of the material in the PEX file, or it will assume that value? And I feel that it will actually override or take that value, that 0, for example, in this case, and the simulation will, well, you know what? It's simple. So we can just run one calculation. Okay, use this. I think it's probably exporting the phantom first, and then it will do the calculation.
Looks like it's having a hard time connecting.
Yeah, so let's check if the shell is on. Oh yeah, well, no, this is online.
You might have to kill the other processes that are running to test the connection. So just go to shell run and hit kill.
So, kill. Oh,
yeah.
Okay. Okay, there it is.
Okay, so
Okay.
it's connected okay. So I think it was maybe trying to connect to your Raspberry Pi first, and it was waiting to time out. Possibly.
Yeah. Maximum time of exceeded. Okay. Okay, let's try it again. Or should I fix the number? Because I think I have the number of shells I think set to 8. So I'm going to change this to number of queues. So I'm going to put here 10 just. It still doesn't connect. I'm going to close it and open it again. It's configurations. Let's see.
It's not able to connect to the shell for some reason.
So I closed it. I'm then going to start MMCTP again. This is going to take a long time to read the phantoms. So are there any questions, general, regarding MMCTP, EGS? Andrew has even more experience than me with EGS, so he can help in some of the questions. So if you have something, just take the mic and shout it out. So you don't have questions, that means either I'm an excellent instructor, so I covered everything, or it means you're not using it. One of two things. Okay.
So Wamid, it says that, is this the plan that you're using? For the
Yes.
test calculation? It says that this beam isn't configured on that shell.
No, because of the 6X, the 6 triple F. That's why. Because I have two beams.
Right. So you won't be able to. I'm worried that you can't run dos XYZ because the.
But I already ran it on. I mean, I have something running,
Okay.
right?
That was on the same cluster, the local one?
Yeah. So this calculation and this calculation is also running there. So if I show you.
Yeah. Because there was an error message saying that beam is not.
I think it's for the other plan, or but you see, it's running there. Those XYZ 8 parallel jobs.
Okay.
Yeah. I'll just wait for this.
While we're waiting, can we go into the beam settings and make sure that it's configured?
Yeah. Okay.
That would be models.
And yeah, configuration. Okay, models.
And then
Okay.
treatment head calculations.
Yeah. You see it automatically, although I went and changed the 6FFF when
Yeah.
we import without any. Okay, so here, so there it is. So this is the Ubuntu cluster, and
Okay.
it's working. I submitted, yeah. And I make sure that I have the same structure on the Raspberry Pi and Ubuntu, my local, virtual machine, so that I use just one input file, a template.
Right. That makes sense.
Yeah. Yeah. Okay. I should start generating smaller phantoms. Now I'm becoming very impatient. So next time I'm going to do a 20 by 20 by 20 by 20.
Yeah. And you don't necessarily have to load them each time. You can turn that option off so they're not loading into memory.
Where is that in
File, those XYZ
okay.
settings.
Those XYZ settings. And import each. Again, this is for Sarin. If you want to use restart option with those XYZ, so make sure this is out. This is not there. Click it.
So you see the option load exfant voxels?
Yes, yes. Okay. Okay.
So then the next time you open this patient, it won't be reading these density values.
Well, I'm just going to close this.
It's a very lengthy process to read those values.
Yes,
It's a text file.
Especially if you have a lot of phantoms with different, then it's really long. I agree.
And this way we can look at that error again too when the beam complains about not being configured.
Okay. But I think that is for either the 6 or the 6, because I don't think I configured the 6FFF. So here, configuration, beam models. So the 6MV is configured, but I don't think I have this configured. So that's why it's complaining, because beam, okay. And I think this is the latest one that it added. That's also not configured.
It's normally it's, so this plan 1. Oh, okay, I see what's going on.
So here, oh, I see now the problem. That's the problem, because I should do this, because the 6MV is configured. I just need to change the beam energy.
Yeah.
Okay, now it should work. We're almost there, so lung is finishing. So we wanted to see if EGS is going to override, if the density is 0, is it going to use the default densities from the PEGS data file? Because there, the density for water, for example, is 1. Density of lung, I think, is 0.26. But we are all in the phantom PEGS phantom file. We have the densities all now are 0. So we're going to see now. So I think it's working. It just uploaded. Okay. and the way you can catch this is if so if the density is 0, that's equivalent to vacuum. No dose is going to be scored in the voxels. And then with MMCTP, it cannot determine, we should get, so I think it's doing an override because now we're seeing some dose there deposited. So dose XYZ actually takes care of that. Okay. Let me make sure that I have select. Yeah, I think it's so. I think it does override. It will whenever it sees the density is 0, it will grab the default density in the PEGS data file and use that. Because I can see it's registering, it's assigning some dose to these voxels. Oh, so the lung now finished. So now finished 100 is reading data and it's important. It's going to download the files, and we should soon see another dose distribution file somewhere here now. I got another exception.
So which plan are you supposed to be under, the 02 or the 01?
0, there should be under 02.
Okay.
Okay. But I got.
I think it's odd that 02 is displaying above 01.
True. With the Windows version, it works okay, but Mac, I get things flipped up. And it's not reversed because I can open another patient where I have multiple plans, I think 9 plans. And you can see after a point, they're in sequence, but it's like the one will be actually the 7th plan, then 2, and then the first plan will be 3, and so on.
Okay. Try and switch between the plans at this point.
So let's I got an exception error, and now okay, let's see if it's going to download again. So when things hang, I think okay, I'm going to show you this again, what I've done. Okay, so now adding those, writing those file, and we'll get here. So sometimes things might not go as planned. So, and this is what happened the previous time. It was stuck on 71% uncertainty. So I opened again, and these are, I think, it shows you the steps or the processes that have been done for the calculation. So if this calculation was started running, it will, this will be clicked. And this option, I just cleared it out. So if I click on this, the system will now, when I tell it to go and try to finish this beam, it's going to go and grab again, try to grab the dose file. And so this is how so now it grabbed it. You'll see another file is going to be actually created. So this is the one with the lung. And let's see the dose view. Okay. Okay. Can you see the difference? Now, this is the Monte Carlo without heterogeneous corrections, and this is the Monte Carlo with lung. So let's look at the profiles. Dose profile, we show the ruler. So this was 0, minus 20, 0. And then we have 0 and 20 and 0. So we'll take this is the variant plan. This is the one without heterogeneity. So it's dose, water, and then this one, dose, and one. So let's put all three and show. And now the trick is y equals to minus 19.5. And we'll normalize all. Okay.
I think you'll have to put enter, type enter after those bottom two, and then hit the normalize again.
Okay.
Okay, it doesn't appear to like that.
So at least these two. Okay, this one is without heterogeneity. Okay, let's make it colorful. The variant one, this one, I'm going to put it as red. Okay, and this one is no heterogeneity. So I'll put water, green, red. This one is going to put, sorry, blue, with water. It changed both. It's really weird. And this one, we're going to put it green. Okay. So the green one, and these are two Monte Carlo calculations, and I would like to have it normalized at maximum. I know why. It should be 18.5, because this is in the build-up region, and there are always problems with Monte Carlo, and so this should, 18.5. Okay, 18.5. 18.5. Okay, so let's see. Yeah, now we have it. Okay, so this is the red one. Is you see here in the water, after the heterogeneity, everything matches. It looks fine. But within the heterogeneity, there is difference between the two material. And I'm not sure, I have to be careful because I'm not sure if I use the same density that Eclipse used in the calculation. I've just put 0.26, but I don't know what was the density that Eclipse used. Although it used, I mean, I'm using lung and Eclipse assumes water, but at least I have to make sure the densities are the same. So I cannot really conclude because I don't have that information now from Eclipse. But if there was a difference, a significant difference in the densities of the two materials, I would suspect that these two, I mean, beyond the heterogeneity, one would be attenuated more than the other. So I would not think that they would be matching. But anyway, I will confirm that next time. So so this is the calculation, and I'm going to repeat it, do it with bone, and also get the calculation with replace that heterogeneity with bone and clips, and we'll look at the result. So any questions so far? One last thing, Andrew, okay, before we conclude today. I want to know how to, because you showed us how to do the calculations with the physics phantoms and so on. Like if you want to do an output, so what should I do? Should I first, because I got confused on that part. Should I first calculate, generate a physics phantom? That should be the first step. So should I go and, for example, do this non-CT phantom?
Well, when you click on that, will it allow you to generate something that's specific to your needs, or?
I don't know. So
I thought last time it gave you an error.
No. Okay.
Okay.
So
well, okay. Let's try and create one.
Yeah, physics. Okay.
Yeah.
Okay. So I got this. Okay.
Right. But then now when you click on it and go into advanced settings.
Yes. And then I change things from the phantom, right? Define phantom.
Yeah, define phantom. So this is where you can set your phantom to be an output phantom.
I tried to do this and I got confused about it. So could you help us? So I want, for example, suppose I want to just get the output of my machine or Monte Carlo, output.
Yeah.
So what should I do here?
I would put 2 mediums.
Okay.
And define. So this one, you always have to put vacuum, I believe. Yeah, vacuum, and then for medium 2. No.
Okay, I see now how it's done. Okay. Sometimes it's confusing. Okay. I have to select which medium, and then from here I assign the material.
Yeah.
Okay.
And then put
here
water.
Water. Okay. So I have them like this, right?
Okay, so that's good.
Okay.
And then define an output exfant file. So click on that one.
Okay.
And if you hit edit voxels.
But which profile is going to, so it's probably going to be on.
It's going to be, I believe, a Z profile.
Okay.
So where do you want the output at Dmax?
Yes.
So then I would define three groups.
3 groups, minimum.
Minimum 0, leave it at 0.
And our maximum will see this. So the first one, this will be just one. So for example, it's at Dmax, let's say 6 MV. This would be, I would say 1.45.
I would say 1.25, but I see what you're saying. Yeah.
Well, it's.
It all depends on how wide you want your next one.
Yeah. Okay. So I'll put 1.45. I want, for example, a 1 millimeter.
Yeah, I see. Yeah, okay. That makes sense.
It doesn't, I mean, you could say 5 millimeters, it's up to you. Okay. And the number in this group, this is going to be 1. And then here, this is going to be 0.1. And this would be 1. And then I will put 30, for example, and this is going to be 1. Make sense?
That makes sense to me, yeah.
Yeah, so for everyone, what I'm trying to do, I'm trying to generate a slab at Dmax of 1 millimeter thickness. So I want the Dmax for 6 is, I'm going to assume it's 1.5. So I want the center of the slab to be at 1.5. So the slab above it, the width of it is going to be 1.45. And then the thickness of the slab of my interest, because the output is probably going to be on this slab, is going to be 0.1. And then I need some material beyond that. So I said 30 centimeters, could put 40 or so. If you want to use a different slab thickness, not 1 millimeter, let's say 5 millimeter, then probably you need to adjust at least the width there. So Andrew was using a 1.25. So in this case, this will be 1.25, this will be 0.5, and then 30 centimeters or 40 centimeters.
Right.
Okay, okay. So, and here it automatically calculates what's the maximum value. So this is at the surface. So my phantom height is 31.55. One thing I think you have to, and correct me if I'm wrong, Andrew, the coordinate system for when you're using phantoms is different than when you're using images, because in images, the y-axis, this is how the y-axis actually represents the depth, and the z represents the slice thickness, or the number of slices, or where you're in the soup direction. But now, if I'm using the physics phantom, I think the z now is actually representing the depth, and the x and y are representing left, right, and super. That's correct, Andrew?
That's correct. Yeah.
So be careful on that. Be careful on that when you're making your factors. Okay. So what are these here now?
So now you have to define the voxels in x and y.
Okay.
So I would say if you wanted 30 centimeters in z, then maybe make it 30 centimeters in x and y as well.
So this would be minus 15.
Yes.
And this would confuse me, low side and high side.
It's very confusing.
Yeah. And here I want to put 15. Let's put minus 15 and 15. Okay. So what are these then?
So if you want, again, 1 millimeter, put negative 0.05.
Okay. Okay. So this is basically, this by default is going to be 3 voxels.
Yes, by default.
Okay.
Yes.
By default. Okay. Now I see how it is done. And from this to this will define the middle voxel coordinates or limits. So this will be minus 0.1, and this will be, actually, if I want a 1 millimeter, this should be minus 0.5.
Yes.
And this will be 0.5. Okay. Okay, so what I have in the X and Y direction, I have 1 voxel. So let's annotate. Let's see if I can annotate. So in the X and Y directions, I have 1 voxel like this. By default, it's always 3, and then a second one, and then a third voxel. Okay. Minimum value, it's here. This is the edge. And then the low side is actually for the middle voxel. This is where the coordinate of this edge here. High size, okay, this is the coordinate of this side of the middle voxel, and then maximum value is this voxel. Okay, clear to everyone? Any questions about that? Okay. Okay, so then here, this is water, and this is side phantom 1. Okay, Andrew, everything's fine now?
Wait, one thing you might want to change, though, is maybe you do want the medium. Well, no, I guess the medium will be air outside, and that's set somewhere else. So you can hit close, I believe.
Yeah, so here then I can select this. Okay.
No, I think you have to go back. You need to go back and put an air value in there as well.
So we'll put this 3. Okay. So vacuum, and then here, this is going to be air. Okay. Medium side phantom, medium. Okay. Close. And here now I can select this to be air, right?
Right.
Okay.
And so you have the option to save this as an EGSnrc default.
Okay. Do that. I wish I did not do that. Okay.
I guess we should not have done that.
Okay. Okay. An out of bound exception has occurred. Okay. So file is going to crash. We'll start with it.
So this time, instead of saving it, you can run the simulation, but it should default to those settings for every beam that you create.
We'll see now if it saved the file. I'm going to load it and just make sure. Okay, so we have the physics, okay, and advanced options. So define pattern. You know what? I'm going to do it again, Andrew, because I'm worried. Oh, let's try to load. Let's load the default. Okay. And I don't.
I'm pretty confident that it didn't save anything.
So far. Yeah, yeah. So that's why it's not a big deal. Very quickly. And let's set direction.
So put it as an output phantom when you go back to that next section.
Okay. And by the way, you can make your phantom so you generate PDDs, not output.
Right. Yeah.
So there will be 1.45. So select on this and then medium inside phantom, that is air and density, sorry, water, and this density is 1. And here we're going to put this as air. So let's close and see if it's going to run without any. Okay, I have a problem. Oh yeah, it's the shell. That's not a problem. Okay. Right. It's not configured on shell.
So you have to save that beam. You did make a change to that beam. You relabeled it. No, it's not here, Wamid. It's the beam energy. I think it's mislabeled.
Oh yeah, because of the yes, because I opened it again. Okay, that's fine. There's XYZ. That's fine.
Okay, there's definitely an issue here. I don't know exactly what it is.
I had problem running this.
It's not telling us where it's having an issue.
Yeah.
You can see, Wamid, that it wrote the input file.
Okay.
So you can open up that input file and see if that looks. Well, I don't think it transferred it. You'll have
you mean okay? Oh, you mean locally, just as a template?
Yeah.
Okay. So we'll do this in documents. MMCTP. It should be under those XYZ or beam, right? Should be here.
No, it'll be under. Go back to the patient. It's in the patient folder where
Okay,
this
DICOM.
No,
so it's in Legal RT, and this is the patient. Okay, and I'm not sure which one, so I'm expanding both of them. Okay, probably it's this phantom.
Yeah.
Okay, so there is the input file. No, this is the we want the physics one. I don't see a physics input file because this is bone, lung, water.
I don't see one either.
Yeah.
Okay. So it's having a hard time creating that file.
Okay. I wish if someone then can try it on Windows on the version, maybe I have a problem with Mac. And I'm going to actually try it at the office tomorrow because I have a I think 10.13 there. I don't have the 10.15. So just to make sure that it has nothing to do with the Mac Catalina version, that there is a problem or a bug there that needs to be fixed. Okay. Okay, so are there any questions from anyone? Dr. Hassam, no questions? I know we're taking you away from, we're doing a lot of radiotherapy stuff, and probably we are now doing MMCTP as a tool for, but I think a lot of us are interested in, you know, using this great user interface tool. But if anyone has any questions, please go ahead. Okay, in that case, then probably we will conclude today our last session, and we will continue next week. So I will try to get I will try to look into first the DICOM header to see where we can catch this triple F or X distinction between beams, and I will do it for 6, 10, and 10 of, I will also get DICOMs for 10 of these plans. And what else we can do? We can look into trying to look into this output issue to define our beam. But in any case, if that does not work at this time, what I would do is I'm going to use this water calculation. So I can just repeat it with a very high, more numbers just to reduce the uncertainties. And then I'm going to grab the dose at a specific better. You actually grab it at 10 centimeter and then divide whatever dose calculated by the PDD to get the dose at Vmax. And that would define my output or conversion from particle, dose to particle, incident particle to monitor units. And I will then use that value, put that value here, the dose X, Y, Z. And probably I will repeat the calculation or maybe have another phantom to validate that I'm getting the correct end use matching that from Eclipse. Of course, there is some always uncertainties on the Monte Carlo calculation, but I'm going to try that just to validate everything is fine or not. Okay? Make sense? Okay, then in that case, then we're going to conclude our session today. Thank you very much, Andrew, for being active with us here. And so now you see you're becoming popular.
Yeah, I enjoy it quite a bit. I encourage more questions too. And if people want to email me as well, I'm available to reply.
And please, if you have, a community, you used to have a community of MMCTP users and so on, just send them the link to register, and they're welcome to join us, and we want to learn from them, learn from their experience.
Yeah.
Okay.
Unfortunately, next week I'm away, but I'll be back again in approximately 2 weeks.
Okay. So I will see with the guys. Probably then maybe we will take a break next week. I will discuss this with them. Take a break, and then maybe continue. Wait for you. We will see. Okay.
Okay.
I'll be in touch with all of you. Okay, everyone. Thank you very much for joining us, and good night and good afternoon for you. Okay. Bye-bye.